This conference
Yeah.
will now be recorded.
Yeah, in the continuation of your the previous session, I'm doing with the continuation. So I think we are seeing the problem. Am I correct?
Yes, sir.
Yes. Yeah, fine. So up to there, I think we had seen the previous session. Am I correct?
Yes, sir.
Yeah. So now let me continue with this one. So they given the non-homogeneous system of linear equations. Then I written the augmented matrix. Then followed by I reduce that augmented matrix in terms of your the row echelon form. So after that I find out the values that is the rank of augmented matrix as well as the rank of the given matrix. So the rank of augmented matrix is equal to the rank of matrix, but it is less than of your the number of unknowns. So now this will happen with respect to what, ma? It gives you your infinitely many number of solutions. Am I correct? Yes.
Yes, sir.
Yeah, that provides you the infinitely many number of solutions. Okay. So that is with respect to this one. Now let me take the things with respect to, see, if it is an infinitely many number of solutions, then how I can able to get the solutions? Yes. If you observe the last row, all the elements are 0 or not? Yes.
Yes, sir.
Now,
Yes, sir.
in that case, you people have to, you people have to consider it as number of arbitrary constants. Number of arbitrary constants. So then how you will get that number of arbitrary constants is n minus r. N minus r, where n is, can you tell me what is that n? What is that n?
Number of unknowns.
Variables. Where n is number of unknowns or variables, whatever it may be the case. Then r is the rank of the matrix. Am I correct or wrong? Yes. Now can you tell me what is the number of unknowns here in this problem? What is the number of unknowns here in this problem? Unknowns are what? 3, and rank is what? 2, which is nothing but what? 1. And we need to select the one arbitrary constant. Am I correct? One arbitrary constant.
Yes, sir.
Then I, yes or no? Yes.
Yes, sir.
Yeah,
Yes,
how will how I will do it as? How I will do it as? Means from the
So
last
let us
row.
consider that arbitrary constant as Z.
Yeah, some other constant. Let me take that other constant. Yeah. That arbitrary constant, I'm just considering it as what, ma? Some other variable. Am I right or not?
Yes, sir.
So let me take the arbitrary constant, let some z is equal to k. This I'm taking. This is one arbitrary constant. Suppose if more than one arbitrary constant means, how you people have to select it as? More than one arbitrary constant means, if it is a two variables means k1, k2 you will take it as. So here only one arbitrary constant is required. So that is the reason why I'm just taking one arbitrary constant as. Yeah. Similarly, you can cross verify as from second row. The equation. What will be the equation from second row? Y plus 2z is equal to 8. Am I correct?
Yes, sir.
Yeah, very good. Next, from first row you will have x plus y plus z is equal to 6. You will have
6.
So now let me take these two equations. Yeah, let me take these two equations. What is one is what? Y plus 2z is equal to 8, and the other one is what? X plus y plus z is equal to
6.
Am I correct? Yeah, that is what the thing. So now just substitute the value of your z as k. Z as k to substitute as what I'll have it as y plus 2k is equivalent to 8 and y is equivalent to what, ma? 8 minus
8
Am I
minus
correct?
2k.
Yeah. Then similarly, substitute y value and z value here. So x plus y is 8 minus 2k. Then z is k, which is equivalent to 6. What will I have here? Minus 2k plus k, you'll have minus k. This 8 will goes to that side. So that is x plus 8 minus k is equivalent to 6. Then x is equivalent to what, ma? 6 minus 8. This minus will happen with the plus. So hence x is equivalent to what? K minus 2. Am I correct? Am I correct or wrong?
Yes, sir.
Yeah, now the values. You take the values. X is equivalent to k minus 2. Y is equal to 8 minus 2k. And z is equal to what, ma?
K, sir.
And z is equal to k. So this is actually the solution for the particular criteria. Am I correct? This is the solution. Am I correct or wrong? Yeah, you people will have a doubt. Sir, here I'm having the as k minus 2, y as 8 minus 2k, and z as a k. You can ask me that, sir, only one value it is there. Then you can call that as a solution. It's a wrong statement. So if you vary the value of your k, if you vary the value of your k, if you vary the value of your k, what will happen? If I vary value of k from minus infinity to plus infinity, accordingly the x value, y value, z value will vary or not?
Yes, sir.
Are you able to follow me?
Yes,
Let us
sir.
say,
Very.
suppose if I take k is equal to, yeah, suppose if I take k is equal to 0, what is your x value? Minus 2. And y value 8. Z value 0.
0.
Am I right or not? Yeah, so likewise, if I vary the k value here, obviously your x value, y value, and z value, it will vary with respect to what, from minus infinity to plus infinity. So that is the reason why, this has what? This has infinitely
Many number of solutions.
solutions. Got my point?
Yes, sir.
Got my point or not? Yeah, sometimes for this problem itself, suppose what I given in the problem, repeat the above problem for x plus y plus z is equal to 6, x plus 2y plus 3z is equal to this. This is the question I had given actually. Am I correct? Yes or no? No.
Yes, sir.
So now, if I consider this, are you following me? Yes. Are you there
Yes,
all?
sir.
Yeah. So the same problem if I had given, suppose if I had given the same problem with an options, the same if I had given with the options. I'm just considering an example. Let me take this example. Now you need to tell the answer for that. The values of x comma y comma z, which satisfies the following condition is. Which satisfies the following conditions is. That is x plus y plus z is equal to 6, x to 14, and x plus 4y is equal to 30. And they given the options. and they given the options like 7 comma 3 comma minus 4, B minus 3 comma 10 comma minus 1, C 3 comma 8 comma minus 5, and D none. This is the question mark. So how you people will solve this one? The same question, I just given an options. Yeah, what will happen for this? Yes, ma. Are you there?
Sir, simply substitute the values of x, y, z on the above equations
Ah,
and check
that is
whether
one
they
of the option.
satisfy. Yes, sir.
Yeah, yeah. So the one option for this problem is you can get you can substitute more. See here, the given in the problem, that is options is x, y, z values. Directly you can substitute these. So and don't judge only one equation more. All the three equations must satisfy. So all three equations must be satisfied. Then only you have to give the answer. That is the correct one. Clear? So that must be satisfied with the three equations. I understand what I'm saying.
Yes, sir.
Yeah, can you check it and give me the answer for that? Which option is satisfying? Which option it satisfies?
C, sir.
Huh? Check it properly.
Yes, sir. C.
It's a wrong answer. Check it properly.
Yes,
Sir,
sir.
D, none, sir.
Huh?
None of these
Someone
satisfies, sir.
saying C. Yeah, someone say, and someone, what about what happened to the second option? What about the second options? Yes.
Sir, second one is satisfied, sir.
Yes.
Option B,
Second
sir.
option.
Yeah, only second option is satisfying.
Yes, sir.
Option B is the right answer. Only one option will satisfy this condition. Option B is the right answer. And you can cross verify more. Earlier, the same problem you done now. The same problem you done with respect to the earlier case. Am I correct? For the set of linear equations, what you done now? What is the value of
Yes,
your
sir.
x there? X is what? Y is what? And Z is what? Z is k. Y is what? 8 minus
8
2k.
minus 2,
And x is what?
K minus 2.
K is, yeah, k minus 2. This is the thing you got it now. This you concluded it as what? Set of linear equations have what? Infinitely many number of solutions. That set of linear equations will have what? Infinitely many number of solutions. So out of infinitely many number of solutions, which one is correct they want? That is what the criteria. So let me take the first option. First option, they provide you x as 7, y as 3, and z as minus 4. So now let me take the first option, that is 7 comma 3 comma minus 4 if I take it as. Now let me take z is equal to how much, ma? Z is how much, which is k, that is minus 4. That means k is minus 4. Then substitute k, that is minus 4 in that. So 8 minus 2 into minus 4. So how much you are having? 8 plus 8. You will have
8
what,
plus 8.
16. Yeah, is the value of your k is 16. Sorry, y is 16? No. So hence, this option is not satisfying. Then go for the next option. Option B, minus 3, 10, minus 1 ongoing. Yeah. So now in this case, z is equal to minus k. Then, sorry, z is equal to k, which is minus 1. Am I correct? Then similarly, y
Yes, sir.
8, 1. So which is how much? Is it 10 or not? So the value of your y is 10. Similarly, check
10.
for x. X is k minus 2. K is minus 1 and minus 2, which is what? Minus 3. So is it
Minus
satisfying this
3.
condition or not? Yeah. So option B is satisfying this condition or not? Then if you want, you can cross verify this third option also. If you want, you can cross verify this third option also, it won't satisfy. So this won't satisfy and this also won't satisfy. Only the option B is satisfies this condition. So hence the answer for that problem is what? The answer for that problem is what, ma?
Option B, sir.
Option B is the right answer. Clear na? Rest of
Yes,
you,
sir. Yes,
Yes,
sir.
sir.
are you getting how to solve problems? Yes, sir. Yeah. So that is how you people have to solve problems. Then one more problem. Note down. Which one of the following statements correctly described the solutions of the system of linear equations? So that is 1 1 minus 3 0 0 0 0 1 5 1 0 0 1 6 2 0 0 0 1 and 2. Yeah, this is the question and the options. Option A, unique solution. Option B, infinite number of solutions. Option C, inconsistent. Option D, there is not enough information. There is not enough information to decide. This is the question, ma. Try to understand the question and give me the answer properly. That is the question. Okay. So try to give the answer for that. Are you able to following me all?
Yes, sir. Yes, sir.
Yeah, try to give me the answer for this question. They just given the correct statement regarding this augmented matrix. So this is augmented matrix. Whether the augmented matrix is in the form of your the reduced Dirac form or not, kindly check it out and give me the proper answer for that.
So unique solution, sir.
Yes. Check it properly. what is the answer? All. I think no one is responding to me.
Infinite number of solutions, sir.
Yes.
Infinite
Yeah, am
number
I
of
audible, all
solutions.
of you?
Yes, sir.
Yeah, fine. Am I audible all?
Yes, sir.
Hmm. Yes. So how you people will have to get the solution for this problem? You cross verify it, ma. See, if I take the middle diagonal elements, if I take this is a middle diagonal elements, yeah, below the diagonal elements are 0, but the condition, first condition is satisfied. What about the another condition, ma? What about the another condition for making the Roekelin form? The number of zeros from top to the bottom, it must be an increasing order. So here you are having 2 zeros, here also 2 zeros, here 3 zeros. So this test, what you people have to do, that again you have to reduce in the form of the augmented matrix. Am I correct or wrong?
Yes, sir.
Then what you people have to do test? By using this element, I need to make this as a 0. So hence, what I need to perform? R3
R3
as what,
tends
ma?
to
R3
R3 minus
R3 minus R2.
Yeah, so that what I'll get as here 1 1 minus 3 0 0 0 0 1 5 1 and then 0 0
0 0
0,
0.
1.
1 1. Am I correct?
Yes, sir.
Then what about the last row? What about the last row, which is 0 0 0 1 and 2? Am I correct?
Yes, sir.
Yeah, this is the part of your then augmented matrix. Then again you cross verify it, ma. Again you cross verify test. You are having 2 zeros.
R4 tends
Zeros, again 3 zeros are there. Then again what you people have to do test? By using this element, you people have to make this as 0. So that is
0.
R4
R4 tends
as
R4 minus
as,
R3.
yeah. Then if I do that, what I'll get as? Then if I do that, what I'll get it?
1 1
Which
minus
is
3 0
1
0
0 0
0
0
0 1
0 1 0
0
0 0
0 0 1 1
hmm
0 0 0 1.
yeah, that's it. This is the part now.
Yes, sir.
Am I correct? Yeah. So now all the conditions it is satisfies. So you can cross verify it as the diagonal elements. Below the diagonal elements are 0, 2 zeros, 3 zeros, and 4 zeros. So this is completely the reduced Roekelin form. Now this is your matrix, and if I consider this the augmented matrix. So now can you tell me what is the rank of your augmented matrix? And
3,
what is the
sir.
rank of your
4,
matrix?
sir.
Rank of your augmented
Rank of
matrix
A
is
equal to 4, sir.
rank of AB is 4. Rank of A is, because this is a
3.
0 row.
3, sir.
Rank of A is 3, sir.
Yeah, 3. So now the condition satisfies what, ma? Rank of AB is not equivalent to what? Rank of A. So hence system of linear equations consisting of what? It is
Inconsistent.
yeah, inconsistent. So it doesn't have a solution. Am I right? Yes or no?
Yes, sir.
Are you getting what I'm saying here? All?
Yes, sir.
The answer for this question is inconsistent, right? This is the answer for that particular problem. So now I hope you understood all these criteria. Clear now? Clear now, ma?
Yes, sir.
Yes, sir.
Yeah. Let me take one more problem based upon that. The value of lambda such that the system, the value of lambda such that the system 31401 lambda 012 into xyz is equal to 211 has a unique solution. Has a unique solution. Option A 1, option B -1, option C real number minus of 1, and option D none. This is the question. So they are asking the particular system. In that particular system, they are asking the value of your lambda for a unique solution. For a unique solution. So come on, tell me, unique solution means what, ma? The rank of augmented matrix is equal to the rank of given matrix, which is equivalent to the number of unknowns. Then such a case you can get it as what? The value of your unique solution. So in such a case you need to get the value of your lambda. So that is what the question they had given. So let me give the proper answer for that. Come on, try to understand that question and give me the answer for that. So how I have to solve that one? Yes, come on. Are you able to following me? Are you able to following me or not?
Yes, sir.
Then give me the answer for that. Yeah, how you people will solve this one, ma? So again, this is what?
Lambda
X is
value
equal-
1. Sir.
Yeah, non-homogeneous system of linear equations. Yes, ma?
Lambda value 1, sir.
No. Yeah, the option seems to be like that only, ma. The option seems to be like that only. It will be tempting, but you need to select the proper answer for that. So this is the most difficult part. Yeah. Now, can you give me that is it is Ax is equal to b. It's a non-homogeneous system of linear equations. If I form the augmented matrix, what I'll get as if I form the augmented matrix 3 1 4 2
0,
1
1 lambda
0 1 2 1. Am I correct?
1. Yes, sir.
Yeah. This is an augmented matrix. So already the first column, the 2 elements is 0. So now I need to do it as what? By using the middle diagonal elements, I want to make this as a 0. So what I'll do? R3 as R3 minus R2. So if I perform that operation, what I'll get it as? If I perform that operation, what I'll get it as? 3 1
3, 1,
4
4,
0 1
0,
lambda 1
0,
0,
0
0,
minus
2 minus lambda, 0.
2 minus lambda
0.
0.
And 0. Am I correct?
Yes, sir.
Yes. I think somewhere you done a mistake, maybe. Is it?
Yes, sir.
Wait more. I just did I given yeah. Sorry, yeah. Actually, yeah, one mistake is there. Sorry. Or else with that problem itself, you can check it out. The answer. The options I will change it. In the options I will do it as the change. Is it okay for you?
Yes, sir.
Yes, sir.
Yes, sir.
No need. No need to change the question. Not a problem. I'll just change the. I'll just change an option. R minus 2. This is. Yeah. Now tell me the answer for this. This is an augmented matrix. So they asked that. What is the question? They asked that they want the value of lambda for what? For unique solution. Am I correct? Yes or no? Then what do you
Yes.
mean by an unique solution? It must satisfy the rank of AB is equal to the rank of A then that is equal to what? The number of unknowns.
Yes.
If it satisfies this, then I have unique solution. Am I correct? Correct or wrong?
Yes, sir.
Yes, sir.
Yeah. If you use your common sense properly, if I take lambda value as 2, if lambda is equivalent to 2, what will happen?
The condition does
substitute-
not satisfy, sir.
0. If I take lambda is equal to 2, if I take lambda as a 2, my rank of AB will be what? 2.
2.
And rank of A is what? 2. But it is
Also
less than 3. So in this case, which solution it will happen? In this case, you will have what, ma? Infinitely many number of solutions only, na?
Yes, sir.
But they are asking what?
Unique
We don't want that.
solution.
They are asking what, ma? Unique solution. Yeah, unique solution means what, ma? Rank of AB is equivalent to rank of A, but which is equivalent to number of unknowns. Yeah. Which value I need to take that lambda value? See, if you use your common sense properly,
Less than 2, sir.
yeah, all the real values except lambda is equal to 2. You can substitute
Yes,
lambda
sir.
as -2 also. If I substitute lambda as -2, what will happen here? This element won't be 0. Am I correct or wrong?
Yes, sir.
Yeah, that means that to make the unique solution, lambda must not be equivalent to 2. All other values, I can take it as what, ma? The lambda value. Am I correct or wrong? Am I correct or wrong? So hence, lambda value, I can take it as what? All the real values except 2.
2.
This is the answer for that problem. Am I correct or wrong?
Yes,
Yes
sir.
or no?
Yes,
See,
sir.
our
Correct.
aim will be what, ma? I don't want to make this as what? I don't want to
0.
make this element does not be 0. Am I
0.
correct or wrong? Yeah,
Yes, sir.
this element does not be 0. That is what my aim. Other than all those, it becomes the lambda value. Am I correct?
Yes, sir.
Am I correct or not? So that is how you people have to solve the problem based upon that. Clear? So the answer for this problem is what? Answer for that problem is what?
R
Real numbers
minus 2.
except 2.
R minus, that is R means real values. If you want, you can represent here. You represent
Yes,
that.
sir.
R means all real values. Okay. Except 2, all other remaining real values. That is that criteria. Got my point? I don't know what is going on today. I'm not getting the
Yes, sir.
response from you.
Yes, sir.
Whether you people are following me or not. Is there any problem?
No, sir.
No, sir.
Yeah. Then try to give me the response. Shall we go for the next problem?
Yes, sir.
Yeah. Write down. Next problem. The values of a P and Q. The values of a P and Q such that the values of P and Q, the system has such that the system x plus y plus z is equal to 6, x plus 2y plus 3z is equal to q, x plus 2y plus pz is equal to 10, has infinite many number of solutions. Infinitely many number of solutions. This is the question. The values of P and Q. The values of P and Q such that x plus y plus z is equal to 6, x plus 2y plus 3z is equal to q, x plus 2y plus pz is equal to 10, has infinitely many number of solutions. Yeah, come on, give me the answer for that. Yes. Give me the answer for that. Yes, ma, how you people will solve it? Are you able to following me? Are you able to
Sir,
follow
P
me?
value should be 3 and Q value should be 2. Minus 2, sir.
2. No, check it properly. Check that properly, ma.
Q value 10, sir.
Yeah, P value 3 and Q value 10, ma. Then I just asked you this question for infinity many number of solution. Those who completed for infinity many number of solutions, can you try for a unique solution and no solution, ma? The values of P and Q. The values of P and Q. So try to listen, ma. Again, which is having Ax is equal to B. This is nothing but what? Ax is equal to B means non-homogeneous system of linear equations. So then you can have a what? The augmented matrix. What is your augmented matrix? Augmented matrix is what? This one. So which is 1, 1, 1, 6. Then 1, 2, 3, Q. Then 1, 2, P and 10. Am I correct? This is augmented matrix, na? Able to following me? Yes.
Yes, sir.
By using this element, I need to make it as a 0. So that is R2 as R2 minus R1 and R3 as R3 minus R1. So if I do that, what I'll get it as? This is 1, 1, 1, 6, which is 1 minus 1, 0, 2 minus 1, 1, 3 minus 1, 2, which is a Q minus 6. Next, 0, 2 minus 1, 1, P minus 1, then 10 minus 6, which will be 4. Am I correct? Then again, by using this element, I want to make this as a 0. So that is R3 as what, ma? R3 minus R2. Then if I do that, what I will get it as here? Then if I do that, what I'll get it as here? Which is 1, 1, 1, 6. This is 0, 1, 2, Q minus 6. Then this is 0, 1 minus 1, 0, P minus 1 minus 2, which is P minus 3. Yeah, 4 minus Q minus half minus plus ma, which gives you what?
10 minus.
10 minus Q, na?
Yes, sir.
Am I correct? Yeah.
Yes,
So
sir.
now this is a diagonal element. Below the diagonal elements, I made it as a 0, hence it is a recurrent form. Now I need to check it out this one. So they asked what, ma? What they asked you? What they asked? First condition. What they asked for?
P and Q value.
Infinite many number of solutions.
Infinite many number of solutions. They want the value of your P and Q. Am I correct? Yeah. What is the condition for infinite many number of solutions? You know that rank of AB is equal to rank of A, which is equal to what, ma? Which is nothing but what? Which is less than the number of unknowns.
Yeah.
This is the condition for your what? The infinite many number of solutions or not?
Yes, sir.
Yeah. When for what values? If I make P this element as 0 and this element as 0, ma, that case only it will happen. So what? The total all the elements in the corresponding last row will become 0. So hence in that case my rank of will be what? AB is 2, A is 2, but it is less than 3. So if I make this will happens only when P is equal to 3 and Q is equal to what, ma? 10. That means this is 2, this is 2, and which is less than 3. So hence this one. This is an answer for your particular question or not?
Yes,
Sir,
sir.
no,
Yes, sir.
yeah, that is how I can able to solve it as. That question is over. But I'm trying to extend that question for unique solution as well as your what? Unique solution as well as your what, ma? The no solution. Yeah, can you give me for unique solution? What is the value of your P and Q? For unique solution.
If P
For
is
unique
not equal
solution.
to 3 and Q is not equal to 10, it has unique solution, sir.
So for unique solution, rank of AB is equivalent to rank of A. That must be equivalent to N only, na? Then only
Yes,
that condition will satisfy. Am I correct?
Yes, sir.
Yeah. So if you observe properly, ma, if you observe properly, that means that rank of AB must be 3 and rank of A also must be 3. In which case that will be existing? In which case that will exist? What is the value of your P? If you use your common sense very properly, if this element is presented and this cube may be any other element, that does not matter. Am I correct or not? See, if this element is presented here, yeah, if this element is presenting, whether if it is getting a 0 also, that does not matter, because one element is presenting, then I cannot able to call that as a 0 row. One element is presented, hence I can call that as what? Non-zero row. Am I correct?
Yes, sir.
Yes,
Yeah.
sir.
So what I'm trying to tell you guys is P is not equal to 3 and Q may be what, ma? Any real value. Am I correct? Shall I write
Yes,
like that?
sir.
Yeah.
Yes, sir.
Q, if you keep that 0 also, this element, if you are making that 0 also, that doesn't affect here. Am I correct? Am I correct or wrong? I'm not getting the response
Correct,
from you
sir.
guys.
Correct, sir.
Yeah, in this case you will have what? All the three things which happens with respect to what, ma? 3. Next, for the last one, no solution. No solution. For no solution means what? What must it have to obey this condition? Which condition?
Rank of A is not equals to rank of AB.
Is not equal to rank of A. This must satisfy. Then only I can call that as a what? The no solution. Yeah. Which case it is?
P equal to
Which
3,
case
sir.
it is? Yeah. That means
P
that
equals to 3
see,
and
if this element is, if I'm making this element as 0, if it is not equivalent to 0, then that is nothing but what, ma? In that case, see, if I consider P is equivalent to 3, if I consider P is equal to 3 and Q is not equivalent to 10, what will happen? If P is equal to 3 means your rank of A is what? Rank of A is
2.
2 and rank of AB is 3, na?
3.
Then that
Yes, sir.
don't have any. Am I correct?
Yes,
Am I correct,
sir.
all of you?
Yes, sir.
Yes, sir.
Yeah, so that is how you people have to solve the problems based upon what marks. That is how you people have to solve the problems based upon what? Yes. The solutions to the system of linear equations. The solutions to the system of linear equations. Are you understanding what I'm saying here?
Yes, sir.
Are you
Yes,
understanding?
sir.
Yes, sir.
Any doubts? Yeah, fastly revise all those things, ma. Fastly revise all those things. This is about the solutions of a system of linear equations. And the last concept is the eigenvalues and eigenvectors. The last concept will be the eigenvalues and eigenvectors. So actually, that is what I can say that which is a theoretical part, ma. That is a theoretical part. Okay. I'm just taking that theoretical part here. These notes also I will send you. Don't get bothered. Yes. Are you getting what I'm saying here?
Yes, sir.
Are you able to following me now, ma?
Yes, sir.
Yeah. See here. Nothing is there. That screen is visible to you.
Yes, sir. Yes, sir.
Yes, sir.
Yeah. See, ma. Actually, this is again the theoretical part. So that is the reason what I'm doing is I will take directly this theory and anyhow I will send you that notes to you guys. Nothing more than ma. So again, for writing all these criteria, it will take some time. The thing, whatever we are having here, that I will send you. Okay, don't get bothered. Okay, are you getting what I'm saying?
Yes, sir.
Yes, sir.
Yeah. Note down the another topic called as eigenvalues and eigenvectors. Eigenvalues and eigenvectors.
మా సార్ డిస్కనెక్ట్ అయినారా? నాన్న సారు డిస్కనెక్ట్ అయిందారు నాన్న?
Yes, sir.
ఓకే ఓకే చూద్దాం. జాయిన్ అవుతారులే, ఉన్నానమ్మా. జస్ట్ నెట్వర్క్ ప్రాబ్లం అన్నట్టుంది, వస్తారు. డోంట్ లీవ్ అమ్మా, సార్ విల్ జాయిన్.
Yes, ma.
సతీష్ సార్,
Sir, yeah.
జస్ట్ నెట్వర్క్ ఇష్యూ సార్.
No. I just disconnected, sir.
ఓకే ఓకే
No problem. Wantedly, I just
Okay,
disconnected because for sharing the notes.
ఓకే సార్.
No issues. Yeah, is it visible to you, Nama? All?
Yes, sir.
Yes, sir. Yes, sir.
Yeah, I'll do one thing. Something happened here. Just wait for that some time, ma.
Okay, sir.
Meanwhile, you revise that one. Meanwhile, you revise it, ma. Yeah, is it okay? Am I audible now, all?
Yes, sir. Yes, sir.
Yes, sir.
Yeah, fine. Note down. Actually, the another topic is which is the eigenvalues and eigenvectors. Actually, this is also the theoretical part, ma. So that is the reason why what I am doing is just try to see the definitions. Okay. Is it visible to you all? Is it visible to all?
Yes, sir.
Yes, sir.
Yeah. So now let me take yeah, leave all those, ma. Anyhow, I'll write all these criteria so that again that copying thing that and all it will take time. Am I right? I'll do one thing. Are you following me?
Yes, sir.
Yes.
Yeah,
Yes,
fine.
sir.
Not a issue. Let me take the eigenvalues and eigenvectors, ma. Eigenvalues and eigenvectors. This is the topic. Yeah. So actually, this is a small definition, ma. Let me give you the definition and I will explain you. So try to note down. Parallelly, you people also note down, ma. A non-zero vector. Yeah, parallelly, you people also write down. A non-zero vector, that is x is not equivalent to 0, that is x, such its linear transformation, such that it's a linear transformation over a matrix capital A is the scalar multiple of the same vector x, that is Ax is equivalent to lambda x, is called as an eigenvector or the characteristic vector. Then continuation and the corresponding values and the corresponding values of the scalar lambda is called as eigenvalues characteristic roots, proper value, and latent roots. Latent roots. These are all the just the synonyms for your eigenvalues. Nothing is there. Let me give you a clarification. Let me give the clarification. Please try to understand here. Is it over? The writing of your definition? Is it
Yes,
over
sir.
the writing? Yeah. There, if you consider properly, a non-zero vector. What do you mean by that? A non-zero vector? Non-zero means it does not equal to 0. Am I correct or not?
Yes, sir.
Yeah. Is a vector. In that case, what people have to keep in your mind, the eigenvector does not equal to 0. So this is not a zero vector. It is a non-zero vector. Okay. So a non-zero vector, capital X, that is such that the linear transformation. Linear transformation means matrix A. See, I just taken a vector capital X. It's a linear transformation means it's a simple multiplication only. Linear transformation means what? The multiplication, nothing more than that. So it is simply you can call it as the multiplication. So a non-zero vector capital X such that it's a linear transformation over a matrix capital A is the scalar multiple. The scalar multiple means what? The lambda value. Same vector. Try to check it out. Here I just taken a vector X. Here also I am getting the value of what? X only. Am I correct or wrong? Here also I'm getting the value as what? X. Am I correct or wrong? Are you understanding what I'm saying?
Yes, sir.
Right? So what I'm doing here is the same vector, I'm just multiplying with the matrix capital A, then it gives your capital, that is a capital X vector with respect to lambda is a scalar. That lambda value I'm calling it as what? An eigenvalue. And X is nothing but what? The eigenvector or not? Yes or no, yeah?
Yes, sir. Correct, sir.
Yes, sir.
A, whatever the vector I'm taking a capital X, that vector I'm just multiplying with a matrix A, that gives the same vector multiplication of the scalar value. That is, the scalar value is lambda, where lambda I'm calling it as the eigenvalue, and X I'm calling it as what? And X I'm calling it as what? The eigenvector. Am I right or not? Yes?
Yes, sir.
Yeah, that is, and the corresponding values of a scalar lambda, I'm calling it as these eigenvalues, characteristic roots, proper value, and latent value. So now, sir, you can have a doubt. Sir, how I can able to calculate the eigenvalues and eigenvectors? How I have to calculate this? So that is, if you take an example of this one, if I take that is, here you got the definition. Here you have a definition, X is equal to lambda X. Yeah, then that lambda X, if I take it as a left hand side, I'll have here what? Lambda into X, which is equal to 0. Then if I take X as a common, if I take X as a common, here A is a matrix and lambda is what? The scalar value. I cannot able to subtract the matrix with a scalar value. So hence I need to do it as what? I need to multiply that scalar value with a identity matrix. That you know that any value or any matrix, if it is multiplied with your identity matrix, will have the same value. So hence the multiplication of that identity matrix does not affect anything. So hence that is the reason why I'm making this as A minus lambda I into X, which is equivalent to 0. Here I just taken X common. That's nothing more than that. You got the point there?
Yes, sir.
You got the point?
Yes, sir.
Yeah, this I'm calling it as eigenvector for finding to find out the value of your eigenvector. Then eigenvalue, how I can able to get it as? For eigenvalues, characteristic equation you people have to do it as characteristic equation. Then what do you mean by the characteristic equation? A characteristic equation. Let me try to give me the clarification. Characteristic equation means nothing is there. A minus lambda is there. For that, if you are calculating the determinant, that's all. So mod A minus lambda I is equivalent to 0. I'll call it as what? I used to call that as what? I'll call that as what? The characteristic
Characteristic equation.
Yeah, the corresponding value, the roots for this characteristic equation. These roots of this characteristic equation, which is simply call it as a C. The roots of this characteristic equation is nothing but what? Your eigenvalues or not? that roots of your characteristic equation, I will call it as what? Yes.
Eigenvalues.
Yeah, eigen values. Got my point? You got my point? Here, this is a simple definition, nothing more than that. Simple definition. See, for finding the eigenvalues, you have to go with the characteristic equation. The roots of the characteristic equation is an eigenvalues, and a minus lambda I into x equal to 0 gives you the eigenvector. First, I'll take one example. I'll go with your conventional procedure. Then I'll give you the shortcut. So no need to go for the conventional procedure. First, I'll take an example. I need to find the eigenvalues and eigenvectors for the corresponding matrix. So first, I'll give you what? The conventional procedure. Then the shortcut I will provide you. Find the eigenvalues and eigenvectors for the following matrix. Which is A, that is 4 to 2 4. This is a 2 by 2 matrix. Yeah, try to follow me here. Please try to follow me here. How I will calculate the eigenvalues and eigenvectors? For eigenvalues, I have to form what, ma? The characteristic equation, ma? Am I correct or wrong?
Yes, sir.
What is the characteristic equation? Yeah, characteristic equation is what? Mod A minus lambda I equal to 0. This is the characteristic equation or not? A is what? 4 to 2 4 ma. Then minus lambda into, which is a 2 by 2 matrix. I need to multiply that 2 by 2 matrix with a 2 by 2 identity matrix. Am I correct? For this, I need to follow what, ma? I need to do what? The determinant. Then what will happen for this? If I subtract this one, this is lambda 0 lambda ma. So if you check it properly, 4 to 2 4 minus lambda 0 0 lambda. Then again, what you people have there? Again, what you will have there? Are you able to following me? Are you able to following me or not? If I subtract this one, 4 minus lambda, 2, 4 minus lambda, which is a determinant. Am I correct? Which is equivalent to 0. Am I correct? Yes?
Yes, sir.
Yeah. Then if I take AD minus BC ma. So AD minus, this is a 2 by 2 matrix. The determinant for that matrix is what? AD minus BC. So if you do it as 4 minus lambda into 4 minus lambda, which is 4 minus lambda whole square minus 4 is equal to 0. It's a simple mathematical calculation. This you people done in your academics. Yeah, again your a minus b whole square. So a square plus b square minus 2ab, which is 8 lambda minus 4 equal to 0. So then this is lambda square minus 8 lambda plus 12
Plus
is
12
equal to 0.
equal to 0.
Yeah, this is the characteristic equation or not? This is characteristic equation. Then what are the roots for this? Roots are what, ma? I think roots will be 2 and 6. Am I correct?
Yes, sir.
Yes, sir.
Yeah. So this roots itself, I'm calling it as what? This roots itself, I used to call it as what, ma? Eigenvalues or not?
Eigenvalues.
Yeah.
Eigenvalues.
So this is a 2 by 2 matrix. You will have 2 eigenvalues. One is lambda 1 is equal to 2 and lambda 2 is equal to what, ma? 6. This is your eigenvalues. Am I correct? Yes or no?
Yes, sir.
Yeah, and the corresponding you people have to do it as what, ma? The eigenvectors. So for lambda 1 is equivalent to 2, I'm calculating the eigenvector. For finding that eigenvector, what I have to do it as a minus lambda I into x is equal to 0. Am I correct? Am I correct or wrong?
Yes, sir.
Yeah. Now this is a lambda 1 is equivalent to 2 ma. So hence I'm taking this as a lambda 1 and this as x1. Correspondingly x1, I'll have the criteria. Yeah, you already taken that one. This is 4 minus lambda 1 2 4 minus lambda 1 and it is multiplied with the 2 by 2 matrix. Now this is which is what? X1 x2 and which is equivalent to what? 0 0. Am I correct? Ax is equal to 0 ma. which is nothing but what? X is equal to 0 is what, ma? Homogeneous or non-homogeneous? Homogeneous
Homogeneous, sir.
system of linear equations. So now you substitute lambda 1 is equal to 2. You substitute that lambda value here. What you will get it as? 4 minus 2. 2, 2, 2, 4 minus 2, 2 will be there. Am I correct? Yes or no? Are you able to following me?
Yes, yes, sir.
Yes, sir.
Yeah, now Ax is equal to 0, ma. It seems to be your Ax is equal to 0. It is a homogeneous system of linear equations. Directly, I want to find out the rank of this given matrix. Yeah. So that means that I need to make, by using this element, I need to make this as 0. Hence, I will to take it as what, ma? R2 as R2 minus R1 if I perform it as. Yeah, if I perform that, what I'll get as here? 2, 2, 2 minus 2, 0, 2 minus 2, 0. Then again, I'll have here what? Which is x1, x2. That is equivalent to 0, 0, ma. So check it out. My rank of A is equivalent to what, ma? This is a 0 row, which is a 1, which is less than the unknowns are what? X1 and x2. This one. Am I right? Am I correct or wrong? Which is having what, ma? Infinite. If you observe what? Are you able to follow me? The previous
Yes, sir.
session, I just
Infinite number of solutions, sir.
in the previous session, you people will have here what? See, this is infinitely many number of non-trivial solution. That means non-zero solution only or not? Non-trivial solution, that is
Non-zero solution.
infinitely many number of non-trivial solution will happens. Am I correct? So for that, I need to take it as what, ma? The arbitrary constant. Let us, here I am having only one constant. I need to take it as, let x2 will be some k. I am taking arbitrary constant. Am I correct? Yes or no?
Yes, sir.
Are you able to following me or not? Yeah, from first row, what you people have it as? From first row, you'll have what, ma? 2x1 plus 2x2 is equivalent to 0. So that is 2x1 plus 2x2 is equivalent to 0. 2x1 is equivalent to minus 2x2. 2 will get cancelled. x1 is equivalent to minus x2. What is your x2 value here? Minus k. Am I correct? Am I correct?
Yes, sir. Yes, sir.
Yeah, now take the eigenvector corresponding to this one. X1 will be this x1 and x2. Am I correct? What is your x1? Minus k. And x2? K. See here, this is k value. If I vary the k, that is the reason why infinitely many number of solutions got it as here. Infinitely many number of solutions. If I vary the k value from minus infinity to plus infinity, if I vary the k value from minus infinity to plus infinity, I'll get what? I'll get it as what? Infinite number of values or not? Yes.
Yes, sir.
Yeah, if I take k as a common here, I'll have a minus 1 and 1. So now the eigenvector corresponding to the eigenvalue, this is called as what, ma? This is eigenvector x1 for the lambda 1 is equivalent to 2. Am I correct? Am I correct or wrong?
Yes, sir.
Yeah, the same procedure you can follow for your the another eigenvalue lambda is equal to 6. That I'll come back. That I'll go to later session. I'll come back with that. Now, what is the definition actually? What is the definition here? I'll make a note point here. I'll make a note point here. Actually, the definition which happens with respect to what? A non-zero vector capital X such that its a linear transformation over a matrix capital A is the scalar multiple of the same vector. This is the definition now. This is the definition or not?
Yes, sir.
Yes. Yeah. Now what is my matrix here? 4, 2, 2, 4 I just taken. Am I correct? Yes or no?
Yes,
and
sir.
x.
Yes, sir.
And x what I got for the lambda value is equal to 2. I got the vector as what? Minus 1 and
Min-
1 only, na? Yeah,
Yes, sir.
minus 1 and 1. So this is 2 by 2 matrix and this is 2 by 1 matrix. Multiply this. Give me the answer for that. Multiply this, ma. Minus 4 plus 2 minus 2 plus 4. What I got it as? Minus 2
Minus
and
plus
2.
2.
Yeah, minus 2 and 2 only, na? Am I correct? Yes.
Yes, sir.
This is minus 2 and 2 only, na, ma? Now, if you use your common sense, if I take 2 as a common, ma, here. If I take 2 as a common, what I'll get it as? Minus 1 and 1 or not?
Yes, sir.
What is this minus? What is this 2 and what is this minus 1 and 1, ma?
Lambda.
Yeah, which is lambda. This is x only or not? Yes or no?
Yes, sir.
This is your a. This is your x. Left hand side is equal to right hand side or not? Is it giving the same statement or not? The definition is satisfying or not? The definition is satisfying or not?
Yes, sir. It satisfies, sir.
Satisfied, sir.
Exactly, it satisfies. That's all. That is the advantage. That is the most important point what you have to keep in your mind to solve your problems on what the eigenvalues and eigenvectors. That is the definition. Can you try the same analysis? Can you try the same analysis for your lambda 2 is equal to 6? Can you try the same analysis for lambda 2 is equal to 6 more?
Yes, sir.
Yeah, the same analysis. See here, if I do tests for listen, try to listen. Lambda 2 is equal to 6 more. A minus lambda 2 I into x is equal to 0. 4 minus lambda 2, 2, 2, 4 minus lambda 2. So once if you understood that earlier properly, then the same thing I'm doing here, which is 0, 0. Am I correct? Am I correct or wrong? Yeah, if I substitute lambda 2 as a 6 here, 4 minus 6 minus 2, 2, 2 minus 2 till happens. Am I correct? Are you following me? Are you following me?
Yes, sir.
Yeah, by using this, again I want to make this as 0. So which is R2 as what, ma? R2 minus R1. So if I perform minus 2, 2, 0, 0 will happens. Then again same criteria will happens. X1, X2, which is equal to 0, 0. Then again the number of arbitrary constants same as it is, ma. Let X2 will be some K, and from first equation you will have minus 2x1 plus 2x2 is equal to 0. From that I can go directly minus 2x1 equal to minus 2x2. Minus 2 minus 2 will get cancelled. X1 is equal to x2, which is equal to k. So now if I represent the vector x2, if I represent the vector x2, which is x1 and x2, so what I'll get it as here? What I'll get it as here? My x2 is x1 is k and x2 is also k. If I take k as a common here, you'll have 1 and 1. So this is my vector or not? Corresponding to the eigenvalue, lambda 2 is equal to what, ma? Lambda 2 is equal to 6. Am I correct? Yes or no, yaar?
Yes, sir.
Yeah. Now you can cross verify again for this. You can cross verify this. You take again ax is equal to lambda x, now whether it is satisfying this condition or not. Check it out. A is a 4, 2, 2, 4 x. Now the vector is what, ma? This is your x. Am I correct? Yeah, 1 and 1. So multiply here 4 plus 2, 2 plus 4, which is how much? Which is how much?
6, 6.
Yeah. From this, if I take 6 as a common, what I'll get it as here? 1 and 1 or not? Yes.
Yes, sir.
Lambda x. So this is what my your a into x. Again, this is satisfying this condition. Definition or not? Yes or no?
Yes, sir. Yes, sir.
Yeah. Actually, this is the process. That is a process what you people have done in your academics. In gate point of view, if you are doing like this, it will take more time. They won't give you, sir, these many pages I was done. Can you give me more than 10 marks like that? They won't ask, they won't give you that. Either 1 mark or 2 marks. Am I right or not? Am I right or not? Yes?
Yes, sir.
Yes, sir.
Now let me take the summary part of this one. If you understand, you try to concentrate much more on this one. Try to concentrate much more. The matrix what I taken here, the matrix A is what? 4 2 2 4 na? Am I correct? For this matrix, you calculated the lambda 1 value is 2 and lambda 2 value is 6. This you already calculated. And similarly, the characteristic equation also you calculated as what? Lambda square minus 8 lambda plus 12. Why I just taken this an example is this already you calculated. Am I correct or wrong? For this matrix itself, you calculated. Yes or no? Yes or no?
Yes, sir. Yes, sir.
Yeah, these values you calculated for the above matrix. Now take down, try to listen here properly. Try to listen. What is the trace of this matrix? Can you tell me what is the trace of this matrix? And what is the determinant of this matrix? Can you tell me? What is the trace of this matrix? Sum of the principal diagonal elements. 4 plus 4, which is how much? 8.
8.
Determinant of a matrix. 16 minus 4, which is how much?
12,
12
sir.
or not? Yes or no? Yes? Are you getting what I'm saying?
Yes, sir.
Yes, sir.
Yeah. If you add the eigenvalues, these two are, you got it as what? The eigenvalues now. What is the addition of eigenvalues? What is lambda 1 plus lambda 2? What is lambda 1 plus
8,
lambda 2?
sir. 8, sir.
8. Lambda 1 into lambda 2. Multiplication.
12, sir.
12 or not?
Yes,
Am I
sir.
correct or wrong? This I can take it as what? Lambda 1 plus lambda 2. This I can take it as what? Lambda 1 into lambda 2. This is sum. This is what? Product, na? Are
Yes,
you able to
sir.
getting me what I'm saying? Yes? You are not giving the response to me.
Yes, sir.
I'm just interlinking, no need to calculate the eigenvalues, no need to see. For characteristic equation also, what is this 8 here? What is this 8? Trace of the matrix or not? That is sum
Yes,
of
sir.
eigenvalues or not? And what is this 12 here? Determinant of a matrix or not?
Determinant of
Product
matrix.
of eigenvalues.
Yeah. What I'm trying to tell you guys is, if they provided you the matrix capital A, for that matrix, directly I can represent the characteristic equation. Directly I can get the values of your eigenvalues. Am I right or not? Getting what I'm saying? And the point what you have to keep in your mind is, sum of the eigenvalues is equivalent to trace of the matrix, and the product of the eigenvalues is equivalent to what? Determinant of a matrix. From this, I can conclude that from this I can take the characteristic equation for a second order matrix. See, the characteristic equation directly I can represent it as what, lambda square minus lambda into that 8 will be what, trace of the matrix or not? Then plus determinant of A is equal to 0 or not? Yes or no?
Yes, sir.
Yes, sir.
Suppose an example. Suppose if I given an example, let me take the matrix capital A is equivalent to some 1, 2, 3, 4. The matrix I had given. Can you give me the characteristic equation fastly for this? What is the characteristic equation for this? Can you give me? Lambda square minus lambda into trace means 5. Next, determinant means what? 4 minus 6, which is nothing but what? Minus 2, which is equal to 0 or
Yes,
not?
sir.
Yes, sir.
Yes?
Sir.
Directly I can tell that answer for this characteristic equation. Once if I get the characteristic equation, then I can go with what? Roots. I can find out the roots for this. Then that roots itself, I'm calling it, I will call it as what? The eigenvalues or not? Yes or no, yeah? Yes or no?
Yes, sir.
Clear na? the point what you have to keep in your mind here. The point what you have to keep in your mind here. Now the way of finding the eigenvalues and eigenvectors, how you people have to calculate the eigenvalues and eigenvectors. Am I correct? Am I correct or wrong?
Yes, sir.
So the point what you have to keep in your mind is, make a note point of this one. Make a note point. What is the first point? Sum of eigenvalues is equal to what?
Trace
Trace
of
of the
matrix.
matrix.
Matrix,
Ah.
sir.
Product of eigenvalues.
Dept, sir.
Determinant of A or not? Am I correct? This again
Yes,
I will make it as, see, the total problem. I mean all the problems I will solve by using this property only. I will show you. I will show you all the problems I will solve based upon this property only. And one more point you have to consider it as, let capital A is equal to, if I take it as this one, A, B, C, D, ma. This is a 2 by 2 matrix. For this 2 by 2 matrix, characteristic equation is what? What's the characteristic equation? Lambda square minus lambda into
80 lambda.
base of the matrix plus determinant of A is equivalent to
80 minus
Plus
BC.
determinant of
determinant
A
of A is
equal to
Am I
0,
correct?
sir. Yes, sir.
Yeah. Similarly, if I go for third order matrix, A is some A11, A12, A13, A21, A22, A23, A31, A32, A33. Then the characteristic equation for this is, try to listen, minus lambda cube plus lambda square into trace of A minus lambda into minus of an principal diagonal elements, M11 plus M22 plus M33 plus determinant of A is equal to 0. Don't get confused. Here usually, listen here. Generally, if I asked you the minors means, you will go with first row, not the first row. So you have to take the minus for principal diagonal elements. You have to take the minus for what, ma? You have to take the minus of what? The principal diagonal elements. Got my point? Getting what I'm saying all?
Yes, sir. Yes, sir.
Is it clear, all of you? Now you understood now what I'm saying. Is it easy or
Yes,
not?
sir.
Is it
Yes, sir.
easy or not?
Easy, sir.
Yeah. Now let me take some properties, ma. Actually, these properties already proven results. That results is required. That results is required to solve the problems. Okay. So let me take the properties of eigenvalues and eigenvectors. Then we'll solve the problems based upon properties. Yeah. Note down. Try to note down parallelly. Yeah. Now you understood now. Is there any doubts in this? So far? So far, is there any doubts?
No, sir.
I think all of you are following me, na? No
Yes,
doubts.
sir.
Yeah, fine. So let me take the properties. So the first most property, note down, the eigenvalues of, parallelly you also note down, the eigenvalues of diagonal matrix, the eigenvalues of diagonal matrix, scalar matrix, upper triangular matrix, and lower triangular matrix are its diagonal elements. Simple criteria. Are its diagonal elements. What are that? What is that? Let me take an example. If I have a matrix like this, 1, 2, 3, 0, 4, 5, 0, 0, 6. This is a matrix. What are the eigenvalues?
1, 1, 4, 6, sir.
That's all.
1,
So
4.
see, below the diagonal elements are 0. This is what, ma? Upper triangular matrix, na? Am I correct? For upper
Yes,
triangular
sir.
matrix, what is the diagonal? What is the eigenvalues? 1, 4, 6.
4,
No need to
6.
no need to calculate. So likewise, you people are having what here? For diagonal matrix, likewise you are having different criteria. That is, for diagonal matrix, scalar matrix, upper triangular matrix, and lower triangular matrix. All the matrices you people are having what, ma? The eigenvalues are what? The eigenvalues are what? Yes,
Diagonal
it's
elements.
it's
Element.
diagonal elements. Am I correct or wrong? Are you able to following me?
Yes,
Yeah.
sir.
Point. If lambda 1 comma lambda 2 and so on lambda n are the eigenvalues of a matrix capital A, are the eigenvalues of a matrix capital A, then the known property only, ma. What is that? Lambda 1 plus lambda 2 plus lambda 3 plus and so on lambda n. What is that? What is the answer for that? Similarly, lambda 1 into lambda 2 into lambda 3 into and so on lambda n. What is the answers for that?
So
Yes.
trace of A, the first one.
Yeah, first one is
Trace of A, and
trace
the
of the
second one
matrix.
is determinant of A.
So that is, this is what, ma? Sum of the eigenvalues, and this is what? Product of the eigenvalues. This is very, very important property here. This property is very, very important. Got my point? All.
Yes, sir.
Yeah. Then our next one. If lambda is an eigenvalue, if lambda is an eigenvalue of a matrix capital A, then A lambda is an eigenvalue of K into A. That means, see here, A is a matrix, lambda is a scalar. Here K is a scalar, A is a matrix. So that is how you people have to write down. These are all directly they asked the statements. These are all the direct statements. So that is the reason why I'm writing, I'm representing the same. Lambda power K is an eigenvalue of A power K. Then similarly, next one, lambda plus or minus K is an eigenvalue of A plus or minus K into I. Nothing I'm doing here. Wherever I'm having the scalar values, that I'm just multiplying with an identity matrix. Wherever I'm having a scalar value lambda, the replica of the scalar value as a K, but matrix is same. So that is Ax is equivalent to lambda x. Vector is same. The matrix is what? A, and scalar value will be lambda. That's all. Nothing more than that I'm doing there. Clear now? Getting what I'm saying?
Yes, sir.
Yeah. Next one. If lambda is an eigenvalue of a non-singular matrix, capital A, if lambda is an eigenvalue of a non-singular matrix capital A, 1 by lambda is an eigenvalue of A inverse. Directly substitution. See, why I'm representing these all is, sometimes they won't give you the matrix. They'll give you simply the eigenvalues. Then they will ask you what is the inverse of a matrix. Like that questions they will ask you. So for that reason only I'm representing these conditions. Are you able to getting what I'm saying here? Mod A by lambda is an eigenvalue of adjoint of A. Adjoint of A. Getting what I'm saying?
Yes, sir.
Yeah, next one more. The eigenvalues of the eigenvalues of the matrix A and A transpose are same. It won't be changes. The eigenvalues of a matrix capital A and A transpose doesn't changes. You can cross verify it as. Okay. In the first example, I just given you upper triangular matrix. Then you can go with the transpose. The same 1, 4, 6 only will be happening. Can you try to check it? This? Yes. The eigenvalues of A and A transpose are same. Okay.
Yes, sir.
Yeah. If lambda is an eigenvalue of an orthogonal matrix, then 1 by lambda is also an eigenvalue of matrix A. Suppose if you want to represent here, what they are telling is, for an orthogonal matrix, lambda and 1 by lambda is also an eigenvalue. That is only the thing they are telling. That's all. If lambda is an eigenvalue of an orthogonal matrix capital A, then 1 by lambda is also an eigenvalue of matrix capital A. They are saying it as. What my point? Understanding?
Yes, sir.
Yeah. Next the another statement. The eigenvalues of symmetric matrix are, it is very, very important. Many more times they ask directly, what are the eigenvalues of a symmetric matrix? What are the eigenvalues of a symmetric matrix? They asked. Option A real, option B 0, option C purely imaginary, options D none of the above. Like that they will ask you. It is very most important. The eigenvalues of a symmetric matrix are real, whereas the eigenvalues of skew symmetric matrix are what? Eigenvalues of skew symmetric matrix are either 0 or purely imaginary. Either 0 or purely imaginary. This is the point what you have to keep in your mind. Very important. For a symmetric matrix, that is a real value. For a skew symmetric matrix, either 0 or purely imaginary. Got my point? Understanding?
Yes, sir.
Yeah, that is the point. Next, last point. Last point what I want to tell you guys is, let me take, if capital X is, let me take that point. If capital X is an eigenvector of, if capital X is an eigenvector of matrix capital A corresponding to the eigenvalue, corresponding to an eigenvalue lambda, then X will also be an eigenvector of, vector for the matrix A power m corresponding to an eigenvalue lambda power m. Yeah, I hope you are not getting this point. Sir, the theory you just given, I'll give an example. I'll make an example for this. What they are telling is, first let me give an explanation. See, X is an eigenvector of a matrix capital A and a corresponding eigenvalue lambda. That is the first statement. If X is an eigenvector of matrix capital A and corresponding eigenvalue will be lambda, and the same X and the same x will be the eigenvector, and the same x will also be an eigenvector of matrix capital A power m with the corresponding eigenvalue as what ma? Lambda power m. This is the explanation they are giving. This is what the point what they are mentioning. You got my point? X is an eigenvector of some matrix capital A corresponding to the eigenvalue lambda, and the same vector capital X is an eigenvalue of some other matrix A power m, corresponding eigenvalue is lambda power m. Their vector does not changes, matrix changing and the eigenvalue is changes. That point you have to keep in your mind. That point you have to keep in your mind. Are you able to following me? Are you able to following me or not?
Yes,
Yes,
sir.
I'll just take an example. I'll take you an example. Let me consider this one. What is the explanation of your, what is the definition of your eigenvalues actually? Ax is equal to lambda x, na? Am I correct?
Yes, sir.
Then from this, what I want to tell you is, I want to take a power, a square x, or simply you take it as the multiplication of this one. A into ax, if I want to take it as. If I want to take it as left hand side, I'm doing this. So what I will get it as here? Left hand side this one, and similarly right hand side a into lambda x or not? Am I correct?
Yes, sir.
Yeah, where a is a matrix and lambda is what ma? Scalar value. Then I can bring out the scalar value outside, and then I can multiply that with respect to what? Ax, na? Yes or no?
Yes, sir. Yes, sir.
Then what is your ax here? What is the value of your ax? That ax I can replace that as a lambda x. Shall I replace there?
Yes, sir.
Shall I? Yeah, lambda x, that is ax is nothing but what ma? Lambda x only, na? Then what is
Yes,
this?
sir.
Is it square x only or not? What is this? What? How I have to represent it as? This is a square x or not? Yes.
Yes, sir.
A square x is equivalent to lambda square x. Am I correct? Then similarly, a power 3x is equivalent to lambda power 3x I can represent. Then similarly, a power 4x is equivalent to lambda power 4 into x. Shall I? And so on, and so on. A power mx is equivalent to lambda power m into x. Shall I write it?
MX. Yes, sir.
Shall I write it? The point what you have to keep in your mind is, with respect to this, the vector is same. Try to listen. Vector is same. See, here also the vector, if you consider the earlier case, this is ax is equivalent to lambda x. This is the definition. Am I correct? This vector, both vector is same. Here also vector is same. But a square matrix is different and eigenvalue is different. Vector is what, ma? Vector is what? Same or not?
Yes, sir.
You got my point clearly here. Is there any doubts? Is there any
Clear,
doubts in
sir.
that? Clear,
Clear,
all of
sir.
you? Yeah. So vector won't be changes, ma. Vector won't changes. The matrix and the eigenvalue will be changing. That's all. Nothing more than that. Clear? Understood, all of you?
Yes, sir.
Yeah. So these are the some of the properties what you have to keep in your mind to solve a problem on eigenvalues and eigenvectors. Okay. Yeah. So let me take a problems based upon that. So go for problems. Yeah. Firstly, give me the first problem. The eigenvalues of capital A is equivalent to 2 minus 1 minus 4 5. The eigenvalues of this one. Option A 1 comma 6, B 2 comma 5, C 3 comma 2, D 1 comma minus 1. This is the
2,
question.
5, sir.
The eigenvalues of this one. What?
2,5, sir.
Yeah. This is how you people will do the mistakes. This is how you will do the mistakes. Try to check it properly. Try to check it properly. I told you many more times. Right?
3,2, sir.
Yes. Huh? Yeah. This is how you people will do the mistakes. What I told. This is
Sir,
not
1,
your upper triangular matrix, third triangular matrix. Yes, ma?
1,6, sir.
Yeah, 1,6 is the right answer.
Yes, sir.
Yeah, I told you that first for a given matrix, they given the matrix capital A, which is 2, -1, -4, and 5. Trace of the matrix 2 plus 5, which is 7. Determinant of A is what? 2, 5 is 10, -4, which is 6. Am I correct? Am I correct or wrong? They given in lambda 2, or these are lambda 1, lambda 2. These are lambda 1, lambda 2, lambda 1, lambda 2. Suppose if I write all the options, all the 4 options here, 1,6, 2,5, 3,2, 1, -1. Are you able to following me? Are you able to following
Yes, sir.
me?
Yes, sir.
Yes, sir.
Yeah.
Yes.
Trace you got it as 7 and determinant you got it as what, ma? 6. Am I correct? Yeah, trace means what? Sum of this one. 1 plus 6 is equivalent to 7. Next, 2 plus 5 is equivalent to 7. Next, 3 plus 2 is equivalent to 5. 1 minus 1 is equivalent to 0. Am I correct?
Yes, sir.
Yes. Yeah, by the concept of your trace of a matrix, it must satisfy 7. So this 2 is not satisfying. So hence you can eliminate these 2 directly now. Only these 2 options is satisfying. Am I correct?
Yes, sir. Correct, sir.
Yes, sir.
Yeah. Now you can cross verify with respect to what? You can cross verify with respect to what? The determinant. Determinant means what, ma? 1 into 6, 6. 2 into 5, 10. Yeah, these 2 things not required. So it is satisfies 6. Is it satisfying 6? Is it satisfying 6?
Yes, sir.
Is it satisfy 6?
No, sir.
Only the option A is satisfying the answer or not?
Yes, sir.
The option A is satisfying the answer or not?
Yes, sir.
So that is how you people have to solve the problems like that. So is there any complication? Is there any complication, ma?
No,
sir.
sir.
Is
No,
there any
sir.
complication? Yeah, can you try 2 more problems based upon that homework? Yes.
Yes, sir.
Yeah, eigen values of, note down the matrix. Homework, ma. This you people have to give me the answer. -1, 3, 5, -3, -1, 6, 0, 0, 3. Options 3 plus or minus I, 3, B, -6 plus 5I, 3 plus or minus I, C, 3 plus or minus I, -5 plus I. Option D, 3, -1 plus or minus 3I. This is the question. The answer for this problem is option D is the right answer. You try to solve that. Okay. Right?
Yes, sir.
Yeah. One more problem. The eigenvalues of another problem 0, 1, 0, 1, 0, 0, 0, 0, 1. I hope you understood the concept. Did you got that point? Yes?
Yes.
Yes,
Same
sir.
analysis, ma. First problem, the same analysis you people have to do it as. Option B, 1, 2, -2. Option C, 1, 2, -1 by 2. And D will be 1i minus I. For this problem, answer A. You try to check it out, ma. Okay? Understood?
Yes, sir.
You try to practice that one. Yeah, next problem. Next problem, try to note down. If one of the eigenvalue of a matrix, if one of the eigenvalue of a matrix is -2, 1, 1, 3, 1, 5, 1, 3, 1, 1. If one of the eigenvalue of a matrix is -2, then the remaining eigenvalues are. Then the remaining eigenvalues are. Come on, try to solve this one. What you will get it as? Yes, ma? What you will have? Yeah, they given one of the eigenvalue and for the matrix, right? That means lambda 1 they had given as -2, and they are asking lambda 2 and lambda 3 values for that matrix. Am I correct? Am I correct? Yes.
Yes,
Yes,
sir.
sir.
The matrix is 1, 1, 3, 1, 5, 1, 3, 1, 1, 1. Yeah, can you tell me what is the trace of this matrix? Trace of this matrix is 7, and the determinant of this matrix is, if you calculate, you will have it as -36 1. If you calculate the trace of the matrix 7, and determinant for this matrix is -36. You know what? You know what, ma? Lambda 1 plus lambda 2 plus lambda 3 is equal to trace of the matrix, that is equivalent to 7. And lambda 1 they had given -2 plus lambda 2 plus lambda 3 is equal to 7. From this, what is your lambda 2 plus lambda 3? 7 plus 2, which is how much, ma? 9. Am I correct?
Yes, sir.
Yes, sir.
Sum of the eigenvalues is equal to trace of the matrix, and the product of the eigenvalues is equal to what? Determinant of what? Lambda 1 into lambda 2 into lambda 3, which is equal to what? Determinant of A, which is -36. Am I correct? Am I correct?
Yes, sir.
-2 into lambda 2 into lambda 3 is equal to -36. Minus will get cancelled. 2 1s, 2 18s. So hence you will have lambda 2 into lambda 3, which is equal to how much? 18 only, na? This you take it as equation 1, and this you take it as equation 2. Yeah, by solving equation 1 and 2. By solving equation 1 and 2, you will have what? Lambda 2 is equivalent to 3, lambda 3 is equal to 6. Check it out. This is the way of solving that particular problem. That is a way of solving that particular problem. Maybe today's class it will extend up to 10 to 15 minutes more. I'll try to conclude this session. So by today we will try to conclude the linear algebra. So maybe it will extend 10 to 15 minutes. Is it okay for you?
Okay, sir.
Yeah, fine. So this problem
Okay,
you
sir.
understood, na? Yeah, this problem you understood or not? Yeah,
Yes, sir.
after finishing of this class, you try to solve that equations. Don't get bothered. Okay. Right? The next
Okay,
problem.
sir.
Yeah, the number of, next problem, the number of real eigenvalues the number of real eigenvalues of the matrix, the number of the real eigenvalues of the matrix 0, 1, 2, 3, 1, 0, 3, 0, 2, 3, 0, 1, 3, 0, 1, 2. The number of real eigenvalues of the matrix are option A 4, B 3, C 2, D 1. This is the question. The number of real eigenvalues of the following matrix are. Yes, how I have to solve this problem? How I have to solve this problem? Yes, ma. How I need to solve this? Any response? How I will solve that one? No response.
Sir, by converting upper triangular matrix.
By converting
Upper triangular matrix, sir.
by converting upper triangular matrix, sir. Yes. Nothing is there. If you try to use your common sense properly, if you try to use your common sense properly, yeah, the given matrix is what? The given matrix is what? If you try to observe this, the given matrix is what? The symmetric matrix. You can check it out. A transpose is equivalent to A or not? Yes.
Yes, sir.
Yes, sir.
So which is a symmetric? Which is a symmetric? For a symmetric matrix, all the eigenvalues are what? Real or not?
Yes, sir.
So here it is a 4 by 4 matrix. So hence for 4 by 4 matrix, you will have what? 4 eigenvalues or not?
Yes,
Am I
sir.
correct? So all are real eigenvalues. So this is how they will ask you the questions, right? Understood?
Yes, sir.
Yeah, next, one more problem. Which of the following, next problem, ma? Which of the following is not an eigenvector of some 2 by 2 matrix? Which one of the following is not an eigenvector of some 2 by 2 matrix? Option A 1 1 transpose, B 1 0 transpose, C 0 0 transpose, D 0 minus 1 transpose. Which option? Firstly, people have to tell that. For this, I already given the answer. For that, I already given the answer. Yes. No response. Are you there all?
Yes, sir.
Sir, C, sir.
What?
C, sir.
Try to understand the question properly and give me the answer.
Yes, sir.
Yena. In the definition itself, I told you that. In the definition itself, I told you that.
Sir,
The
it's B.
eigenvector is 0. That is not a non-zero vector. A non-zero vector, I told you that. So here they asked you not an eigenvector. So this is an eigenvector, this is an eigenvector, this is an eigenvector. Then this is what? Zero vector, na? The eigenvector does not be 0. So hence option C is the right answer. So eigenvector is what? Non-zero vector. Am I correct? Am I correct or wrong here?
Yes, sir.
Are you able to following me or not?
Yes, sir. We are following you, sir.
Yeah. Next question. If 1 0 minus 1 transpose, if 1 0 minus 1 transpose is an eigenvector of 1 minus 1 0 minus 1 2 minus 1 0 minus 2 1 1, then the corresponding eigenvalue is. Then the corresponding eigenvalue is, they will ask you. How you people will solve this question? How you will solve this one? Directly you can go with this what ma? The definition. See, you know what the definition? They simply they given what ma? The eigenvector. This is X and the matrix they had given A. And they are asking what? The eigenvalue lambda. This will happens with what? Ax is equivalent to lambda x, that you know that. Am I correct?
Yes, sir.
In that you know Ax, then lambda value you need to calculate it as. Am I correct? Am I correct or wrong? So take left hand side.
Yes,
A is
sir.
what ma? 1 minus 1 0 minus 1 2 minus 1 0 minus 2 1. That is A. Then x vector. Here they given this as a transpose ma. It is a row wise. If I do the transpose, what I'll get as here? Column wise only or not? Yes?
Yes, sir.
Yeah, this is 3 by 3 matrix, this is 3 by
Yes,
1
sir.
matrix. The final result will be what? 3 by 1 matrix only will happen. So multiply and give me the answer for that. Multiply and give me the answer for this. You will have 1 0 minus 1. Check it out properly. Check it out properly. This is equivalent to what ma? Lambda into x only na. This is Ax. This is lambda x. And lambda value will be what from this? Lambda is what?
1,
1
sir.
or not? You got my point? This multiplication you do after finishing of class, don't get bothered. This multiplication after finishing of class you do it as. But getting what I'm saying? Are you getting
Yes,
what I'm
sir.
saying? Yeah, the same problem, same thing for the matrix. For the matrix 4 2 2 4. For the matrix 4 2 2 4, the eigenvalue corresponding to the eigenvector is corresponding to the eigenvector 101 101 is option A 2, B 4, C 6, D 8. The same thing. Here also they given what? Here also they given a matrix capital A, X they had given, and they are asking the eigenvalue lambda. The same analysis what you done for your earlier case, the same thing you people have to do it as. The same you have to do it as. Come on, try to give me the answer for that. Yes. Come on. Are you able
C,
to follow
sir.
me? What ma? C, yeah. Yeah, lambda value will be 6. The same again I'm taking Ax is equivalent to 4224. X is 101, 101. Then this is 404 plus 202. Then 202 plus 404. Then what I will get it as? Then what I will get as?
It's not 6.
Yeah, 606 and
602.
606. From this, if I take 6 as a common, I'll have here what? 101, 101. So this gives you what? Lambda into x. Am I correct? So the value of your lambda is 6. The answer for this is what? 6 or not?
Yes, sir.
Yes, sir.
Yeah. Then one more problem. That is the last problem. Note down. The matrix capital M. The matrix capital M is equivalent to -2, 2, -3, 2, 1, 6, -1, -2, 0. Has the eigenvalue -3, -3, and +5. An eigenvector corresponding to the eigenvalue lambda is equal to 5 is 1, 2, -1 transpose. Then one of the eigenvector of m power 3 is option A 1, 8, -1 transpose. Option B 1, 3√2 -1 transpose. And C is 1, 2 -1 transpose. D is 1, 1 -1 transpose. What is the answer for that? I think for this also I given you the point. Try to give that answer for that. Question seems to be big mark, but if you use your common sense, that is very easier manner. Nothing is there. They given the matrix capital M and the corresponding eigenvalues are -3, -3, +5.
Yes.
For 5 the eigenvector has 1, 2, -1 transpose they had given, and the eigenvector corresponding to the matrix M power 3 they asked. Can you give me the answer for that?
Yes, sir.
What is the answer? What, ma?
Yes, sir.
No. So this is the thing I'm telling you guys. Concept you have to make it as properly. I told you what is
Yes, sir.
the statement I made you in the initial. The point what I have to make, what I mentioned there. See, a power m x is equal to lambda power m x. Vector is constant, that is the same. Vector is same. Matrix differs and the corresponding eigenvalue lambda differs. Vector does not changes. Vector is not changing. Got my point? Got my point or
Yes,
not?
sir.
Then
Yes,
what's the
sir.
answer now?
Yes, sir.
C, sir.
For
C.
making you people as a confused, they will give you the options like that only. You have to what you people have to do it as. You have to clear that confusion. For that reason only, this is what I'm doing here. Getting what I'm saying here? See, the matrix capital M they are having. The matrix capital M they are having. For that matrix, they are having the eigenvalues -3, -3, +5. These are the eigenvalues. These are the eigenvalues. And the corresponding, see, for one eigenvalue, they are taking it as the eigenvector capital X. That is what? 1, 2, -1 transpose. This is the thing they had given. And they are asking, what is the eigenvector corresponding to the matrix M power 3? They are asking. Eigenvalues may be changes. We don't know the eigenvalues. But what is the condition? What is the condition of your last point? Your X will be same or not? It won't be changes.
Yes, sir.
So your answer will be what? What is your answer? Option C is a right answer. So here, what you people have to keep in your mind is your m power 3x is equivalent to lambda power 3 into x. Eigenvalues changes. Eigenvalues are changing, but vector is changing. Vector doesn't changes. Vector won't be changes. Got my point? Got my point?
Yes, sir.
No
Vector
response.
does not.
Sir.
What I'm saying?
Yes, sir.
Yeah. So this is about the eigenvalues and eigenvectors, ma'am. If time permits, I will make one more problem session on these linear algebra, and I'm having the last one application of these eigenvalues and eigenvectors. That is a Cayley-Hamilton theorem. It's a simple thing, ma'am. Just 5 to 10 minutes, not more than that. Are you okay with that? See, if you are completing this, then we'll start freshly the calculus part in the next session. Just 5 to 10 minutes, not more than that. Okay?
Okay, sir.
Yeah. So thank you. That is the last concept for today. It won't take much more time. Yeah. So this is an application of your eigenvalues and eigenvectors. Cayley-Hamilton theorem. Cayley-Hamilton theorem. Ma. So simply I can represent this as CHT. Cayley-Hamilton theorem. So why it is required is the applications of this is it is used for finding the powers of a matrix. Finding the powers, both the positive and negative powers of a matrix. That is like a square, a power 4, a power 10, then a power minus 2, a power minus 1, and so on. This is the most peculiar application for your Cayley-Hamilton theorem. Clear? Then what is the statement? I hope you already seen in your academics. It is very, very important question of your academics. Maybe it is a 10 marks question, I think so. Am I correct? Am I correct? It is a 10
Yes,
marks
sir.
Yes,
question.
sir.
Yeah, state
Yes,
that
sir.
Cayley-Hamilton theorem and solve the below problem by using Cayley-Hamilton theorem. They will ask you that. So can you tell me what is the statement of your Cayley-Hamilton theorem? Every square matrix satisfies. Every square matrix satisfies. Every square matrix satisfies what? Not getting response from you. Every square matrix satisfies its own characteristic equation. Its own characteristic equation. Its own characteristic equation. This is the most statement which you have to keep in your mind. Nothing is there. Every square matrix satisfies its own characteristic equation means, see the earlier example. I just taken on your previous example for giving an eigenvalue and eigenvector. Capital A is what, ma? Capital A is what? 4224. Am I correct or wrong? For this, what is the characteristic equation? I got it there. What is the characteristic equation? Lambda square minus 8 lambda plus 12 is equivalent to 0 or not? This is the characteristic
sir.
equation or not? Yeah. So by Cayley-Hamilton theorem, what you people have to do is you need to replace each and every lambda value with respect to a matrix. That is a statement of your Cayley-Hamilton theorem. Every square matrix satisfies its own characteristic equation. So if I replace this by Cayley-Hamilton theorem, what I will do is wherever I'm having lambda, I can simply replace it as what, ma? A value. So if I replace that, what I will get as here? Check it out. A square minus 8a plus, see, check it out here. It's a constant value. I cannot able to add and I cannot able to subtract the constant value with a matrix. So to avoid that, what I can say that the multiplication or addition or subtraction, I can multiply that constant with a identity matrix. That point I already given you that. So that is 12 into I, which is equivalent to 0. Am I correct or wrong? Am I correct or
Yes,
wrong?
sir.
Yes, sir.
Yes. Yeah. So that is the part of this one. So from this you can get it as what? This I got it as. This is the Cayley-Hamilton theorem. By Cayley-Hamilton theorem, I can do it as. So now a square is equivalent to what I will get it as here? 8a minus 12a or not? If I take this that side. Take that side, I'll have here what? Equal to 8. Yeah. I'm asking you guys only, am I audible or not?
Sir, your voice is breaking, sir.
Yeah, now is it okay? Now is it okay? I got a call, so that's the reason why.
Yes, sir. Now it's okay, sir.
Yeah, no issues. Am I audible now?
Yes,
Now
sir.
am I audible? Yeah, fine. So this is the value of your a square, which is 8a minus 12y. Then if I want to take the value of my a cube, if I want to calculate a cube, so what I will do it as, I have already a, multiply that a square with a, then I will get a cube value only or not? Yes or no?
Yes, sir.
Then what is your a square value? 8a minus 12y.
8a minus 12i.
Yeah. Then what we will have here? If I multiply 8a square, this is a into a square minus any matrix is multiplied with your identity matrix, you will have it as what? The same matrix. That is 12 into
A.
I will have it as. Yeah. Then again, you know what? This is your a square. Again, what is your a square value here? 8a minus 12y. That
8a
also you have to
minus
substitute.
12i.
So 8a minus 12y minus 12a will be there. Then what is the answer for that? Then what is the answer? 8 8s 64a. Then 8 12s. How much, ma? Come on. What is that 12 8s?
96, sir.
72.
72. What, ma? Where are you? 12 8s 96. Not 72. They won't allow the calculators in the GATE exam point of view. You have to use your mind, right? Yeah, don't get bothered. 12 8 96. So which is 96i minus 12a. Then can you tell me what is 64 minus 12?
52a.
4 minus
52a minus 6i.
yeah, 96i. So now the value of your a cube is what? What is the value of your a cube? 52 minus 96i. Am I correct? Am I correct?
Yes, sir.
This is how you people have to solve the problems based upon your Cayley-Hamilton theorem. Suppose from this, if it is there asking a power of 5, a power you people have to get is suppose for this problem itself, if I asked you what is the value of your a power 9, what is the value of your a power 9, you will have a doubt, sir, how much time I have to require, how much time I have to calculate, so that takes much more time, sir. Like that you people will feel it as. Am I correct or not? Because nowadays you people are very familiar with what, you are using your smartphone. Am I correct or not? Yes or no? Why you don't need all these criteria? So if you use your common sense very properly, let me take an intermediate value in between. If I calculate some a power 4 as, if I take a power 4 as some 55a minus 99i, if I got it as, and just assuming if they are asking more than values, don't get bothered, don't feel bad, right? So this much question they had given, how I have to solve it as, don't faces that and all, whether I'll get a pass or fail, don't think in such a way. Clear with my point? So every problem there will be a solution, right? The way how you are utilizing, the way how you are using your common sense is very, very important for solving a problem in competitive exams, right? So that is what I'm saying is, if I got the value of your a power 4 as this much, then can you give me the difference between a power 3 and a power 4? There is a small litigation will be there. That litigation, if you are finding, then the rest of the criteria is over. That's all. What is the difference between your a power 3 and a power 4? What's the difference between your a power 4 and a power 3? Come on. Huh?
Minus 3.
What minus 3? This is plus 3. This is
Plus
also
3,
what?
sir.
Plus 3. Yeah, both are
Yes, sir.
added. Both are added to 3. Then similarly, can you count up to a power 9? How many terms are there? A power 5, a power 6, a power 7, a power 8. Means how many terms? Total how many values I need to take it as? 4 values, na? Am I correct?
Yes, sir.
Yes. ఆకలేస్తుందా? ఇంకా టైం ఉంది కదా. Yeah, means 4 times I need to multiply. That is a 4 into 3. How much more? 12 I have to add it now. For the both
Yes.
12 I have to add it as. Yeah, what is the answer for that? If I add 12 based upon this, if I add 12, if I add this 12, what will I get it as here? This is 67 A minus how much it is? 111, if I'm correct.
Yes, sir.
Am I correct? Yeah, this is the answer for your a power 9. And try to keep in your mind whatever it may be their values, like a power 3, a power 4, a power 5, a power 6, whatever it may be the value they are asking, the final answer must be in A and I, the matrix A and I. So see, don't skip, don't stop the problem by here itself. Sir, I just substituted the value of your A square here. I got 8A square minus 12A, I got it as, then I will close the session. So not like that. Every answer must be in the part of your Cayley-Hamilton theorem. It is in the form of your A and I, whether it may be plus A or minus A, whether it may be a plus I or minus I, whatever it may be the case. Clear up my point? Clear up my point? Are you understanding what I'm saying? Are you understanding what I'm saying? All.
Yes, sir.
Yeah, that is how you have to do it as. Then in this problem itself, Seema, why I'm giving all the combinations of the problem is the rest of the problems I will give an homework for you guys. So in this problem itself, I'm giving all the different variations. See, the earlier in this problem itself, you got it as what? The a square value is how much? A square value is how much? 8a minus 12y only, na? 8a minus 12y only or not? Is my a square
Yes,
value?
sir.
Yeah, you have it. Sir, you told me that positive powers only, not about the A inverse. That is negative. Yeah. Now I want the value of your A inverse. I want the value of your A inverse. Yeah, from this, how I can able to calculate it as? I'll simply multiply with the A inverse. So this A inverse, A square is equivalent to 8A inverse minus 12I into A inverse. Now, can you tell me what is this? A inverse A square. What is the value of this? S, come on. A inverse into A square, you will have A only, na? Am I right? Nara?
Yes, sir.
Then A inverse is nothing but what? You know, this is I, which is 8I minus 12 into A inverse. Because any matrix, if it is multiplied with your identity matrix, you will have what? You will have what, ma? The same matrix only or not?
Yes, sir.
Yes?
Yes, sir.
Yeah. So now you have here what? 8I minus 12A inverse is equivalent to A. From that, minus 12A inverse is equivalent to A minus 8I. Then minus 12, if I take that side, what will happen? What will happen? What is the A inverse value? What is the A inverse value? 1 by 12 into this minus goes to that side. So 8I minus A. Am I correct? Am I correct or wrong?
Yes, sir.
Yes, sir.
This is the value of your A inverse. This is the value of your A inverse. Getting what I'm saying here? Getting what I'm saying here? All.
Yes, sir.
Yeah. Suppose in the same thing, if I want to get the value of your A power minus 2, the same thing if I want to get A power minus 2, what I will do it as? For this itself, I will go with what? Suppose if I want to get A power minus 2, simply what I will do it as? A inverse, I will multiply A inverse with A inverse. Then what is 1 by 12 into 8I A inverse minus A inverse. Then again I will substitute as. I will get the answer or not? Yes or no? Am I correct? Are you there?
Yes, sir.
Yeah, this is how you people have to solve the problems based upon this the Cayley-Hamilton theorem. I hope you understood. In this Cayley-Hamilton theorem, nothing is there. I will give you some of the problems as a homework. Please try to solve that. If at all you have any queries or any doubts, I will give the clarity. Okay. Getting what I'm
Okay.
saying?
Okay, sir.
Yeah, I'm writing the homework problems, ma. Meanwhile, if you have any doubts, you can ask me that. Meanwhile, if you have any doubts, you can ask me that. Or you can note it down parallelly. In blue pen, whatever I'm writing, that are answers, ma. Okay.
Yes, sir.
Are you able to follow? Yeah, that is the first question. Then next. So please try to solve, ma, so that you have an idea. You can get the analysis. All the answers must be in the form of your A and I's. Okay. Right?
Yes, sir.
Yeah, try to note down this. Try to note down kindly. Are you noting down? Are
Yes,
you
sir.
noting down or not? Yeah, note down, note down. So these are the problems you have to keep in your mind to solve the concepts of your the Cayley-Hamilton theorem. These are the problems. Yeah. So now down. And how you people are doing, ma? How you are writing the notes, is that and all? How you are writing the notes, is? Yeah.
We
Anyhow,
are
sir
right.
is
Sir.
what, ma?
We
Yeah,
are
anyhow,
writing
sir
very.
is sending the PDF. Are you writing running notes?
Yes, sir.
Sir.
Yeah, you people are writing. It will be better, ma. Anyhow, I'm sending the PDF for just what? For cross verifying that one. So if you are see, I'm very clearly telling you that for mathematics, if you are practicing, then only you will get success. Otherwise, you will be stucking only. So all the methods will be, yeah, that is stored in mind, but there is no use of that. There is no use of that one. So please try to practice much more, right? So if time permits, I'll make one more problem session on this linear algebra. So this is the concept of your linear algebra. So I hope so there is a much more difference from your normal academic classes to these GATE classes. So how you people are feeling about this?
Yes,
Yes.
sir. Yes, sir.
Yeah.
Difference is there.
Now can you tell me? What, ma?
Feeling easy manner,
Yeah, I'm
sir.
not getting what you are saying. Yes.
These are the easy methods, sir.
Yeah. So that is how you will make it as. So from past 8 to 9 years, we are teaching the same concept, same things. So we are in a way that how easily, if I impose to a student, then they will receive it as. That is what our thing. So by the time to time, we will change the different criterias. Clear with my points? Clear with my points?
Yes,
Yes,
sir.
sir.
Yeah. So that is about your the linear algebra concept, ma. Whenever the next session, we'll start with the calculus part. Okay. If at all, if it requires for
Okay, sir.
calculus, some basics of calculus I will send you. The notes, the basics of calculus I will send you. So if time permits, before calculus, you try to go through it. As clear now? If at all you have any doubts, you can ask that.
Okay,
Okay?
sir. Okay, sir.
Okay, sir.
Yeah, any doubts? And inform to your students, I mean inform to your friends. Next Tuesday, Wednesday, Thursday, Friday, Saturday, you will have a class. Okay?
Okay, sir.
Okay, sir.
Yeah, all are following me?
Yes, yes.
Yes, sir.
Yes. Thank you. Any doubts?
Thank
Do
you,
you have
sir.
any doubts? Yeah, any doubts you are
No, sir.
having?